Hi everyone, I'm here to present about abstract data types. My name is Christabell. I'm pursuing BE Biomedical in Seth Institute of Technology. My instructor name is Ms.Pabitha Praveen. Let's go to the topic. First of all, data types such as in, float, double, long, etc. are considered to be inbuilt data types, and we can perform basic operations with them such as addition, subtraction, division, multiplication, as you all know about that. Now there might be a situation when we need operations for our user defined data type which have to be defined. These operations can be defined only as and when we require them. So, in order to simplify the process of solving problems, we can create data structures along with their operations. And such data structures that are not inbuilt are known as abstract data types. In short, ADT. Abstract data type is a type or class for objects whose behavior is defined by a set of values and a set of operations. The definition of ADT only mentions what operations are to be performed, but not how these operations will be implemented. It does not specify how data will be organized in memory and what algorithms will be used for implementing the operations. It is called abstract because it gives an implementation independent view. The process of providing only the essentials and hiding the details is known as abstraction. Here, here we see a flow chart. There is an application program, which could be any application program, that connects with the functions through interface. And there is a data structure includes array and linked list in the memory. The data structure is connect either functions either as public or private. So these represents the abstract data type. The user of data type does not need to know how the data type is implemented. For example, we have been using primitive values like int, float, char data types only with the knowledge that these data type can operate and be performed on without any idea of how they are implemented. So, a user only needs to know what a data type can do, but not how it will be implemented. Think of ADT as a black box in the aeroplane, which hides the inner structure and design of the data type. Now, there are three ADTs, namely list ADT, stack ADT, queue ADT. The first ADT is list ADT. The data is generally stored in key sequence in a list, which has a head structure consisting of count pointers and address of compare function needed to compare the data in the list. The data node contains the pointer to a data structure and a self-referential pointer which points to the next node in the list. The list ADT functions is given below, that are getOff, which means return an element from the list at any given position. Insertoff, insert an element at any position of the list. Removeoff, remove the first occurrence of any element from a non-empty list. RemoveAtOff, remove the element at a specified location from a non-empty list. ReplaceOff, replace an element at any position by another element. SizeOff, return the number of elements in the list. IsEmptyOff, return true if the list is empty, otherwise return false. IsFullOff, return true if the list is full, otherwise return false. The most important concept related to list is that of position. In other words, we perceive that there is a first element in the list and a second element and so on. So, define a list to be finite, ordered sequence of data items known as elements. This is close to mathematical concept of sequence. We all have an intuitive understanding of what we mean by a list. We want to turn this intuitive understanding into a concrete data structure with implementations for its operations. Ordered in this definition means that each element has a position in the list. So the term ordered in this context does not mean that the list elements are sorted by value. Of course, we can always choose to sort the elements on the list if we want. It's just that keeping the elements sorted is not an inherent property of being a list. For example, the list ADT can be used for lists of integers, lists of characters, lists of payroll records, lists, and even lists of lists. The second ADT is stack ADT. In stack ADT, in stack ADT implementation, instead of data being stored in each node, the pointer to data is stored. The program allocates memory for the data and address is passed to the stack ADT. The head node and the data nodes are encapsulated in the ADT. The calling function can only see the pointer to the stack. The stack head structure also contains a pointer to top and count of number of entries currently in stack. There are several functions in stack, namely push off, insert an element at one end of the stack called top, pop off, remove and return the element at the top of the stack if it is not empty, peek off, return the element at the top of the stack without removing it if the stack is not empty, size off, return the number of elements in the stack, is empty off, return true if the stack is empty, otherwise return false, is full of, return true if the stack is full, otherwise return false. Here the main two operations of stack, which is push operation and pop operation. Stack is basically called as first in last out. It's nothing but, if you can see it in the push operation, the elements are inserted inside, like from bottom to the top, but here in pop operation the elements are taken out from the stack from the top to the bottom, so it is called as first in and last out. Therefore, either we can store items to stack or we can get them back to stack. Hence, inserting items to it is called push operation and retrieving them back is called pop operation. Again, when the stack is in overflow state, we cannot perform push operation. Likewise, and in underflow states, we cannot perform the pop operation. The last ADT is queue ADT. The queue abstract data type follows the basic design of the stack abstract data type. Each node contains a void pointer to the data and the link pointer to the next element in the queue. The program's responsibility is to allocate memory for storing the data. Here are some functions of queue ADT, which is enqueue off, insert an element at the end of the queue, dequeue off, remove and return the first element of the queue if the queue is not empty, peek off, return the element of the queue without removing it if the queue is not empty, size off, return the number of elements in the queue, is empty off, return true if the queue is empty, otherwise return false, is full of, return true if the queue is full, otherwise return false. Abstract data type in C++ have been defined through this presentation. Hope you all understand this. Thank you.